Hello, everyone, and welcome to today's SANS webcast, Maniacal Keyboards. My name is Randall Jones. I'm the Offensive Operations Marketing Manager here at SANS, and I will be moderating today's webcast. Today's featured speaker is Kevin Tyers. In his career, Kevin has worked in government, telecom, healthcare, and financial industries focusing on network security, incident response, and tooling. He's the head of cyber intelligence engineering for a Fortune 250 company, co-founder of DC 480 in Phoenix, Arizona, and is a Security 504 instructor for SANS Institute. If during the webcast are you on, Kevin?
Yes, sorry, I lost audio there for a second. Can everyone
Oh,
hear me?
no problem. I can now, so I believe we are good to go. If you can't or you have any trouble, just go ahead and throw it out there in the chat and I'll look out for him.
Awesome. Well, thank you so much for that introduction, and thanks everyone for spending a little bit of time with me, either this morning or afternoon or evening, wherever you're coming from. Um, Thanks again for that very nice introduction. Today, we're going to be talking about something that you've probably not seen many talks about, if any. We're going to be talking about human interface device attacks and the intersection of those with keyboards. Again, as was mentioned, my name is Kevin Tyers. I'm a 504 instructor, which is like one of my favorite things to do. If you haven't taken that class, you definitely should. My day job, as was mentioned, is I'm a threat intelligence developer. I run a team for a large payment company that you've probably paid some of your pals with. And if you've known me for any length of time, you know that I am an ultra keyboard nerd. I got started in keyboards probably 5 years ago, and I picked up just a regular old mechanical keyboard with MX Cherry Blues, which are clicky switches. That was cool, but then I really started to want to tear it apart and build my own and learn about this whole thing of keyboards, and it's now led me here today. So I have been doing technology, information security, or hacking, for almost 20 years now, which feels kind of wild to say. And there's a part of me that definitely has a hacker mindset. I like to break into things. I like to abuse systems. I like to use things in ways that people never intended. And I think that's really fantastic. And a lot of my friends are the same way. But I also know that a lot of us have this sort of like maker part of us as well. We want to solder things. We want to plug things into a breadboard. We want to write code. We want to release things. And there's those two parts of us that I think are beautiful. And in the union between those two aspects, keyboards exist because there's a lot of cool hacker stuff you can do with keyboards, and there's a lot of cool maker stuff you can do with keyboards too. And I hope by the end of this talk, you are inspired to go out and make your own keyboard and put some attack payloads on there. So to really frame why this is a really interesting vector for information security, let's talk about human interface device attacks briefly. So a human interface device attack is, traditionally we would think of it like a USB rubber ducky, where you have someone with a thumb drive that is able to type into a machine, you plug it in, and it can run commands. So let's just step back and think. If you were in front of a machine and all you had was access to that machine and a keyboard, no mouse, just a keyboard, what could you do? Well, the answer is pretty much anything. I'm a Mac user, for instance. I use Spotlight all the time. I actually really don't use my trackpad all that often unless I'm just web browsing. Same thing with Windows, right? GUI R, bring up that run command box and you can start running any command that you want. So then you can start thinking, all right, even if I didn't have access to a mouse, like what could I do on these machines? And some examples of that is you could download and run a file, right? That may be ransomware, right? Which would be terrible. You could open a netcat backdoor, which would be kind of a common thing that we see today in our demos and the code that I'm going to talk about. You could launch a fork bomb. And you're thinking, well, that's funny. That might be kind of a prank. But actually, one of my earliest clients in the halcyon days of the early 2000s was a manufacturing company that had one of those servers that was running all of their machines to create the items that they created, that was running on old software from a vendor that was out of business. And it was a very huge deal that never went down, that there was never a power outage or the machine didn't lock up. And so we really had to be careful about that server. So imagine if a disgruntled employee came in and plugged in a thumb drive and launched a fork bomb on it, right? They could end the business. That could be an existential event. You could add a syskey. You could disable Windows Firewall. You could grab the the Wi-Fi pre-shared key. There's just a ton of different things that you can do if you only have a keyboard and access to a machine. So here's a couple examples of HID attack devices. The one on the left, which is the USB rubber ducky, is probably the most famous one, but there are other form factors that these attacks can come in as well. That one on the right looks like a regular lightning cable, but when you plug it into your machine, it's able to send keystrokes. So these devices, one of the most common scripting languages, it's not the only one, but it's probably the most common, is called Ducky Script. So here we have a Ducky Script example for launching a netcat backdoor on a machine. So we plug it in and it does GUI space, which will bring up Spotlight. It waits half a second. So when you're writing Ducky Script payloads, it's really important that you let your payloads take a second between each command so that you know that it runs correctly, because these things type very fast. So you don't want to overload the computer and its ability to keep up with the commands you're sending it. Then we type in terminal and we hit enter. So it's going to bring up a terminal window. Then we make a FIFO, backpipe device in this case. We hit enter. We then send the string of nc-nl8080, temp backpipe bin bash. We're not going to go into the magic of how that happens, but if you're interested, we do cover that in Sec 504. And we hit enter, and then we put this in the background. We disown it. We exit out of the terminal window. We close the terminal window, and this happens very fast. And at the end of this, I now have a open backdoor listener on your machine that is running a bash shell. So I can issue commands to that. So here's the demo.
Future Kevin, we'll take it from here for the next couple minutes. So let's take a look at this beautiful device that I have here. At first glance,
apologies.
It appears to be just a standard thumb drive, right? We have a USB-A connector on there, nothing too crazy, but actually this is a USB rubber ducky. And I'll be running the demo here on a 2020 M1 MacBook Air. Now, I love my Macs, but if you've used a Mac before, you know that you gotta love and live that dongle life. I don't actually have a USB-A connector on this laptop, so I'll be using this dongle, to change from USB-A to USB-C. You'll see that even with that, this demo will still work. So let's go ahead and plug it in. Got it the first time, that's awesome. And let's go ahead and plug in here. So go ahead and push in, click. You can see my hands, no trickery going on. All right, so what you just witnessed is we brought up a terminal window, and then we had a netcat listener started that is able to send and receive commands and output from bin bash, which essentially gives us a remote shell. And you are going to be able to connect to the shell over the network, assuming there's no firewall or switch policies in place that block you. But this is a way to open up a backdoor on a laptop. So let's go ahead and verify our work here and go into terminal. And I'm going to do netcat 127.0.0.1 port 8080. You would use the remote address of the machine if you were connecting over the network here. We hit enter. And it looks like nothing's happening, but that's actually a good thing. That means that we've connected to our shell, so we can type who am I as an example command to see that I'm running commands on this machine, which is pretty awesome. So let's go ahead and kill this out, and we will take a look at the internals of the USB rubber duck. So pulling this out here. So you can see, again, it looks pretty standard here. So let's go ahead and break this case open, which you'll need to do if you want to change the payloads, which you want to do. So we go ahead and open that up. And here, right, you would look at this and you may not know initially that it's, something different other than just a USB drive. But here you can see we have our little micro SD card that has our actual payload on it. And when you plug it in, if you want to rerun payloads more than once, just say for testing purposes, and you have the casing off, you can actually click this button right there, and that will allow you to rerun your payloads multiple times. So that was a cool little quick demo. All right, back to you, future Kevin.
Thanks, Past Kevin. Appreciate it. So one of the times that I actually have used this sort of, it wasn't on an engagement, it was during an office prank. We had a gentleman who worked on a team with me a few years ago who he, for some reason, never locked his machine, but he would always turn off his monitors. And I thought that was some of the strangest like security through obscurity I've ever seen in my life. And it bothered me because I work on a threat intelligence team and there's really sensitive things that this person had on their laptop. So I decided that one day I was going to pop a shell and play a little prank on them. So this guy's name is Vinny. Vinny gets up and he goes to the bathroom, turns his monitors off. And I called my friend Blake and I'm like, hey, Blake, keep an eye out for Vinny. And I just roll over to his machine. I pop in my rubber duck because I had the payload all ready to go. It launches, it gets a shell, and I go back to my desk and I connect to it, make sure everything works. About a minute and a half later, he comes back and sits down and starts working. Now, if you've ever used a Mac before, there's a really fun command called say, which makes your computer speak to you. And since I was able to control his machine, I waited for him to sit down and sort of get built in, and I just started sending say commands, saying, I really should lock my machine. And so his machine's talking to him. He has no idea why this is the case. He does the very logical thing of muting his machine. Now, the problem with that is that since I had a shell, I could use OSA script to not only unmute him, but also turn his volume as loud as possible. And so I did that and just put it on a loop. I can't let you do that, Dave. I can't let you do that, Dave. I can't let you do that, Dave. And from that day forward, he did lock his machine. So I would say mission accomplished on that. But it was kind of a fun example of using this, in real life. Oh.
All right. Thanks.
Don't need to see the demo again. There we go. Cool. So we talked about hit attacks, right? Sort of the overall approach that whatever you can do with a keyboard and access to a machine, you'll be able to do something awesome. So let's talk about mechanical keyboards for a little bit, and then we'll kind of join the two together. So a mechanical keyboard is similar to a standard keyboard or a membrane keyboard, as it might be known. So on the left here, that those black 4 keys and that little diagram there, I'll walk through that real quick. So it's like a standard membrane keyboard. You have your key caps, which are the actual things that you press, and then they plunge down into a layer. It's like silicone, and it presses down a plunger, and then under that plunger, you can see that those little like traces on there with the circles. That actually has 2 pieces of metal that when it's pressed down will connect and complete a circuit. And that's a signal to the PCB running the device to send a key code, across a USB. And that's fine, that's cool. And mechanical keyboards are not that different, but let's take a look at the diagram on the right. So you can see the the orange pieces are the housing, and this is the plastic that actually holds everything together. And that can be really significant depending on the type of feel you're looking for with the keyboard or a switch. And then in the middle, that green piece is called the stem. Now the stem is really probably the most well-known part of mechanical keyboard. If you've ever heard someone say, oh, I have MX Cherry Blues on their machine, what they're talking about is that stem size, right? So, or that stem that they're using. And the stem will impact whether it clicks or not, whether there's a bump when you type or not, all that. And then there's a spring in the bottom of the housing that will sort of change how heavy the key feels. And then there's a metal leaf in there that actually the stem will press 2 pieces of metal together to complete the circuit there. So it's a little more complicated than a regular membrane keyboard, but it feels a lot better to type on. So that's what makes something a membrane versus a mechanical keyboard. And I know that there's torpor boards, which are sort of a weird hybrid of the two. We're not going to talk about those today. We're talking about sort of the traditional Cherry design here. So why would you want to get into mechanical keyboards? Most people think of them as just annoying noisemakers, but they're way more than that. Not every keyboard is clicky, for instance. In fact, the keyboard that I use day to day is silenced. It's very, very quiet. So you would use them because they're nice to type on. They just feel good. I've put hundreds of thousands of keystrokes into all my different mechanical keyboards, and each of them feels great. It's also really fun because you can do some DIY hardware that you can use every day. I did a conference badge a couple years ago, and we chose a commodity off-the-shelf solution. It was an Adafruit thing, because we wanted people to be able to take our hardware and hack on it and do things with it, as opposed to getting these really cool badges that you have to have like a J tag or something to actually mess with. Now, the reason I'm bringing that up is that I think keyboards are really great for people who want to do hardware hacking, because we've all written code to flash onto an Arduino to flash an LED. That's cool. Maybe we even hooked up a sensor or two. But usually we don't end up using those electronics in our day-to-day life. Whereas if you build a mechanical keyboard, that is something you're going to use day in and day out until something on it fails, and it's going to take a long time to fail. So I think that's really cool. I also appreciate the level of nerdy detail that is available. If you want, you can just grab a MX Cherry Blue keyboard off Amazon. It's going to be a good keyboard, right? You'll enjoy using it. But if you really want to get into it, there's force actuation graphs, there's custom made switches, there's lubricating your switches, there's building your own, there's designing your own PCBs. The sky really is the limit with the detail that you can go into with mechanical keyboards, which is something that really appeals to me. And the community is really nice, right? You can go on the Mechanical Keyboards Reddit, which is a pretty friendly place, or you can go on Geek Hack, different areas like that, to learn more about the hobby, see new products that are being released. It's cool. I'll say the one thing that is unfortunate is it can get a little expensive. I've probably spent too much money on keyboards, but I don't regret it. So the thing that really blew my mind open about mechanical keyboards was I was building keyboards for a little bit, and I kept hearing about something called QMK. And QMK is the Quantum Mechanical Keyboard Framework. And what this does is it allows you to write firmware for your mechanical keyboards. So you can actually map keys however you want. You can put in macros, which we'll look at more in depth. You can do a bunch of different things to make your keyboard experience even better. This is a well-supported project that's on a ton of different keyboards. And again, we'll dig into the SendString macro command and how that interacts with what we can do with something like a USB rubber ducky here in a moment. So here's an example of a QMK configuration, right? This is what's called a 60% board, and it looks pretty close to what you might find on like a standard laptop. 60% boards are a very common form factor for DIY builds. But you can see here, right on the top is just a big comment that just sort of lets us visualize what the key map looks like. And then down here in the bottom half is the actual codes you have to put in for the keyboard to send. So you can see the top left corner is keyboard escape, and then one next to that is KC1, which is key code 1, 2, 3, 4. Just looks like a standard keyboard. But you can really make that whatever you want. If you wanted that top left key to be enter, it could be that. You want it to be shift for some reason, have at it. You can map it to however you want. So you can map keyboards however you want, which is pretty cool. I mean, especially if you want to develop your own key map beyond just QWERTY or Dvorak or Colmark or whatever. So Colmac, I believe. Anyway, let's take a quick look at my keyboard for a second, and I'll show you how I use some custom configurations, and then we'll talk about the actual hacking in a moment. So this is the keyboard that I use. This is my travel board. It is what's called a plank. It has 48 keys. I really like small keyboards. I'm a big fan. If you check my Twitter, actually, I posted a picture of my daily driver this morning if you're interested in seeing what that looks like. It's actually a split keyboard as well. So, we have all of our standard keys on here, but you might be thinking, well, Kevin mentioned he was a developer, and I don't see any symbols. I don't see parentheses or brackets or anything on here. Where are those? Where's the numbers? What do we do? Well, using QMK, I'm actually able to do what's called multiple layers on this keyboard, and it's really nothing different than the abstraction of using the shift key, right? You don't have a lowercase a and a capital A key. You just use shift to change what that key does when you tap it. It's functionally the same thing with my keyboard. So this left key here that I've highlighted, it's traditionally called the lower key. The lower layer is my symbols. So that means I have exclamation mark, @ pound sign, goes along the line. And then I've actually put in some of my own custom symbols on here. An example here is the walrus operator, or gopher, if you're a Golang user. And because I don't want to have to type $= every single time I want to do that, I just want to have one key that I can hit real quick, and it puts that in there for me, and it works super well. As you probably guessed, right, that jump on the right side, or also called upper, is what gives me access to my numbers and my F keys, right? That's pretty neat. Now, on my keyboard, I've developed my own custom layer that has a lot of, Kevin-specific functionality that I think is really useful. So I have an IPv6 numpad there on the right-hand side, and you'll see I am a lazy network engineer, so I have a 255 key, so I don't have to type 255. I just hit one key and it gives it to me. But then you'll notice those little hack keys on there. And by using QMK SendString macros, I actually have some offensive payloads that are on this, on this keyboard that I have at a moment's notice. If I'm, let's say, doing an engagement, or I'm walking around the office doing an internal engagement, I'm just ready to go and launch those. And the nice thing about this is, with the USB rubber ducky, it's kind of hard to change the payload out. It's really easy if you have time and preparation, but if you're on site and you realize you have the wrong operating system, or you need to change something, it can be kind of a pain. So what I do is I load up a bunch of different attacks that I might want to do on my keyboard, and I just have it ready to go. Now, might it be a little bit suspicious if you have a keyboard and you're plugging it into everyone's machine? Maybe, but what I've done at my current job is I've carefully cultivated a personality that everyone knows. If Kevin comes to your machine to help you with something, he's plugging in his own laptop, or excuse me, he's plugging in his own keyboard. So, that's sort of my way of getting around that suspicion. And actually, I was flying home from Augusta, Georgia one time. Augusta is a very small airport, and I was going through TSA, and they saw my keyboard in my backpack, and they took it out, and they're like, well, what is this? And I said, well, it's a keyboard, right? It's not a big deal. And obviously it's not a keyboard that people are used to seeing, and so they made me actually plug it in and like type on it to show that it wasn't anything crazy. But obviously they were relatively friendly, but I thought, wow, if I was traveling across a potentially hostile border, like, it would be very hard for them to be able to figure out if I had malicious code on this board or not, if they didn't know the exact keystrokes they were right to press to actually get it to execute. So here's just an example of what that configuration looks like in QMK for my active board. I call it the moon grid layout. It looks pretty normal, but you can see I have the bottom one is my nums layer, or my personal layer that I have like my IPv6 numpad on, and you can see in the upper row there is this bash shell here. And this gives me a bash shell on a Linux machine. And I'm changing out payloads all the time, but I usually always have that one on there because I just really love that payload. You saw me use it in the video demo a few slides ago. So I've mentioned it a few times. Let's talk about SendString very specifically. So SendString works essentially the same as like a USB rubber ducky, in that you configure it to send keystrokes, and when you plug it in and you hit that key, it'll send all those keystrokes just as fast as it can into the machine. And so really anything you can do with the USB rubber ducky, you can do with SendString macros. It's just a matter of translating those, and I have a solution for that in a minute too. So, if you already have a bunch of USB rubber ducky payloads that you like, you can just put them on your keyboard and have them good to go. Here's an example of what that looks like. This is essentially doing the exact same thing that we saw in the Ducky script earlier, of doing command space, or in this case is left GUI space, and then waiting, sending terminal and tapping enter, waiting a second, and then typing in all of our commands to get our backdoor listener, disowning the process, and exiting out. It's the exact same thing. Now, it's not as friendly as Ducky script. Ducky script is very elegant and simple to use, but it is essentially just as powerful. And because of the simplicity of Ducky script, I actually wrote a piece of code called QuantumDuck that you can go grab right now. It's actually has the honor of being my most starred repo on GitHub, and I'm very proud of that, where you can go and take Ducky script and turn it into QMK SendString macros. Now, there is a little bit of assembly required to get these to work properly within your key map. And if you have any questions, just reach out to me. I'll have my email at the end of this. But this is fantastic because there is already so many great Ducky script payloads out there. And all you have to do is take those, put it through QuantumDuck, and it will allow you to just put a bunch of those on your keyboard. The one thing I will caution is that keyboard memory is not as expansive as USB rubber duck memory. So there are certain payloads that might be too big, or there might be a limit on the number of payloads you can put on your keyboard. It shouldn't limit you too much, but it is just something to be aware of. You know, because I've definitely used rubber duckies to drop like small binaries, which may not be appropriate for QuantumDuck. So just as a heads up there. And here is a gigantic QR code if you want to scan. Trust me, it just goes to GitHub to take a look at QuantumDuck and pull it down and check it out. So we have talked about sort of the offensive side of things and what we can do. Now let's talk about the blue team. Let's put on our defender hats here. Well, how can we detect hit attacks in general? And this is something that I've worked with a lot of insider risk teams lately inside my company, and then friends who work at other companies, and they are scared of things like the USB rubber duck, and rightfully so. So how might we detect some of these? My favorite detection by far is velocity. These keyboards don't type at the same speed as a normal human being. They type very, very fast, right? So I, went out and I got banned off some typing sites so I could figure out how fast these things typed, compared to how other humans are. So using like 10 fast fingers, which you can see ahead of time what words you're supposed to type. I used QuantumDuck to throw those onto my keyboard, and I typed it in, and immediately got banned. It was pretty awesome. So there's a couple pieces of software out there that are, I would say, more POC quality, but you could take and upgrade yourself to make them like maybe production ready for your environment. One is Duck Hunt, which is a Windows piece of software that will look for very fast typing speeds, and then we'll inject keystrokes or try to kill out the command. There's also a piece of software that I wrote called Deck Detect, which is for Mac OS X, and what that does is it looks again for that very fast typing speed, and then I open up a notepad window to try to capture whatever is being put into the machine, as opposed to letting it go into a terminal window or whatever. So again, Deck Detect is not ready for the big time, but feel free to check it out, steal it, do whatever you want to do with it, because I think there's a lot of promise in velocity-based detection for these attacks. Something else that I've been tinkering with is like pattern detection rules, because think about how you type and think about how a user in a non-information security environment might type. And then, there's probably some like in the domain of all possible typing combinations, we put it through a function. There's some codomain of like actual things that people are going to type. And I would be very surprised if, Dave from HR was typing in GUI space terminal, right? That is just a weird thing for Dave to be typing. Whereas like Janice on the help desk, right, it's probably legit, right? Janice is most likely not doing something weird. Looking for things like SystemNet Web Client, which is very commonly found in some PowerShell payloads, that can be huge. And then looking for X strokes or key presses since a space or an enter. And you're like, well, what are we looking for there? What we're looking for there is base 64 encoded payloads. So a lot of malware that I've seen uses base 64 encoding to get around some basics detection. And it is, if we're typing, right, and the longest words that we're going to type on any regular basis are probably 12, 14, 16 characters long, maybe. And it would be very weird to suddenly have 150 characters typed with no spaces in between any of those characters. So that's an interesting detection as well. Now, could it be someone's just like pounding, face rolling on a keyboard? Yes, but it also could be someone trying to use say a QMK enabled keyboard or a USB rubber ducky to put a base 64 encoded payload onto, say, a Windows machine. So I hope I've inspired you by now to maybe go build your own. And I'm going to touch on this real quick. This is an area you can spend a lot of time, and I've spent a lot of time on this. But if you want to build your own keyboard that's capable of having these QMK SendString macros on there, here's a great place to get started. We need to talk about form factor first. Whenever I know people get into mechanical keyboards, the first gut reaction they have is, I need a full 104 or 108 key keyboard that has a full numpad and everything on the right. And usually as they go along, that keyboard gets smaller and smaller and smaller until you end up like me and you're only using 48 keys. I will say finding a full-size keyboard that you can do completely DIY is actually very difficult. If you are trying to do that and you want one of those, I actually recommend you look at a 96 key keyboard. The Melody 96 is a great example of that. This top one actually is a keyboard I built for a friend of mine. That he really wanted a numpad, And so I was able to build him that, and he loves it. It's his favorite keyboard. At least that's what he tells me. The bottom left-hand corner is that 60% board. We saw the configuration example of that recently. So that is a very common form factor to find. And that's actually the keyboard that I recommend people build for the first time because it's pretty easy to put together. And in the bottom right-hand corner is a TKL, or a 10 key list, which means it has pretty much all your normal keys except for the number pad on the right-hand side. Those are not the only form factors, right? So we also have macro pads over there. We have a Space Cat macro pad on the left that has up to 8 keys on it. You have 2 key macro pads, or my son there, you can see him holding up a gigantic key switch. It's, you know, pretty big. You can have a gigantic hack button if you wanted, and that one clicks pretty loud. So it's very satisfying to use. And as long as you have a PCB that you're able to flash this on, and you can use just like a Pro Micro to do this. That's actually what runs many of my keyboards, is just little Pro Micros. You can just flash it on there and have whatever form factor you really want. So I use what's called a 40%, and that is quite easy to find. You just go to olkb.com. You can buy what's called a plank. It's awesome. 60%, super easy to find. Again, that's why I recommend it for people. 10 keyless, yeah, you can find it, but 108s or 104s, that extra 4 key difference is like if you have media keys, can be very, very hard to find. So don't get your hopes up too much. I see group buys for them sometimes, but not that often. So what do you need to actually build a keyboard? Well, you're going to need to get a case, and you're going to need to get a plate. And those are sort of the housing things that keep everything together. And you're going to need a PCB. Now, this is the part where I see a lot of people go wrong after this talk, and they want to build something and then they buy a PCB, but they don't look for QMK. It is absolutely critical that the board that you buy supports QMK if you want to put really cool payloads on it. A lot of keyboard manufacturers will have their own, you know, like custom configurator, and you might be able to replicate some of the functionality here, but trust me, QMK is the way to go. It is very extensive on what you can do with it, and it's really not hard to use. You're going to need some stabilizers, and what those are for is, you know, let's say you have a long key like a space bar, you have a piece of wire under that keeps it from flopping back and forth. It just makes it feel nice when you use it. You obviously need some switches. I recommend Zelio switches. They're a little bit more expensive, but they feel just fantastic to type on. And then you'll need some keycaps. And keycaps is where you can really get in trouble. You can go on Amazon and get, a bag full of keycaps for $30, $40, and they're good. Or, you can be like me and spend literally $200 for a set of keycaps, every few months, because I definitely have a problem. The keycaps are definitely sort of the vanity aspect of this hobby. So yeah, don't even get me started on artisans, which can cost like $100 a piece, which is pretty crazy. So if it's your first time, right, I recommend trying to find a kit. OneUpKeyboards.com, that's where I recommend pretty much everyone go buy kits from. They've been awesome. They have great PCBs that you can use. My little brother Trevor, who's also an information security professional, built his first keyboard off there, and he loves it. Mechanical Keyboards and Geek Hack are great places to go get guidance and check out. One thing, especially as we come out of the pandemic, that I recommend people do is try to go to local keyboard meetups, because then you can try a bunch of different boards and try out different switches, and you don't have to spend all your money to try different things out, which has saved me a lot of money, because I thought I wanted a particular type of board. I got a chance to use it and said, meh, this wasn't for me. I used to not recommend Glorious Mechanical Keyboards because they didn't support QMK, but actually their Glorious Mech Keyboard Pro appears to, it does now support QMK. I haven't heard how good the support is, so I'm not, standing behind that as a recommendation, but it is something you may want to look into and do a little research to see like, oh, hey, how is QMK running on there? In keyboards, there is a concept of an end game, which is the keyboard after you've built all your other, after you've defeated your previous keyboards, you have this end game keyboard, which is the keyboard you're going to use for the rest of your life. And it's sort of said tongue in cheek, because if you're into keyboards, you're probably never going to stop building keyboards. But, if you're looking for that board that might be the sort of one and done that you build, I think the Clue board very specifically is just an amazing board that supports QMK. And it's beautiful, it's heavy. It's super cool. I recommend you go check it out. So here's an example. of this. You can take a look at this in the recording afterwards to see like, all right, like what are the different components here? This is pretty much everything you would need to build a keyboard. And you see it's about 230 bucks, right? It's not cheap. Most of my keyboards range anywhere between 200 and 400, depending on the parts that I put in them. But for me, they're things that I love to build, and I'm willing to spend a little bit of money on it. But it's actually funny because my daily driver is actually probably one of my cheaper keyboards. I think it's probably only about $180 for all the components for it. So yeah, it's definitely cheaper than a $5 Dell keyboard though. I cannot tell you how much I appreciate you spending this bit of time on Friday with me to talk about something that I love. I love to give talks, and whenever I get to talk about keyboards, right, I think you can tell I'm kind of beaming talking about this topic. So I hope that this has inspired you to make something. I hope that this has inspired you to think about how you might detect hit attacks in your network. I hope this has maybe inspired you to write some code or fork, QuantumDuck and add your own features. I really cannot thank you enough for spending time with me. If you ever see me at a SANS event, please come up, say hello, chat with keyboards, chat with me about keyboards. I have my email there in the bottom right-hand corner that you can reach me at, and that's my real email. So please don't sign me up for any spam list. That about does it for me. So I'd love to open it up for questions.
Oh, that's great. So I'll just reiterate, we had a couple of people ask about the slides. The slides will be posted with the recording, likely later today, maybe tomorrow. So you can get back to that recording and the slides at the same webcast registration page where you joined. So one question I had here was, how are these payloads detected? That was when you were looking at the detection pattern ideas slide?
Yeah, so that's a very good question. There's a variety of different ways that you can detect these payloads. Really what it comes down to it is you have to be able to key log on a machine to actually detect these payloads, right? I have not dealt with any EDRs directly that are able to keylog. They may be able to. I am not an EDR expert, not claiming to be. In the smaller organizations that I have helped with this kind of stuff, that they actually wanted to do this, they usually choose like a smaller user segment. They don't have it running on their servers or anything necessarily. I will help them maybe use something like Tanium to push out a script that is able to run, because the way that the detections will work is you can actually hook into like what I call the key stream, either through Windows or Mac, that lets you see all the key presses. And then based on that, I have an internal counter to see like how fast something is going. If you pull up deck detect specifically, which is code I wrote, take a look at that and see kind of how that works. And if you have any specific questions, again, hit me up on why I chose to do certain things. But yeah, essentially you need to have a keylogger, which sounds kind of weird, but with the amount of like, I don't want to say corporate spyware, but it's kind of what it is that we have on our professional laptops, it's really not that out of the question for that to come in. You could
Cool.
also probably have something register when a new keyboard device gets mounted on the machine. You just have to look for that like in the, say, Windows event log.
Cool, and just for folks listening in, I did put the GitHub links to those tools in the chat window, and then once again, they'll be in the slides, of course, available later today. I think this is an extremely relevant question. What switches should I get to annoy my coworkers?
Oh my goodness, that's a great question. You should get Novel Keys box navies. They are by far the loudest switches I have ever heard, and they feel just fantastic to type on. Actually, that keyboard that I built for my friend that I mentioned, the 96, has navies on it, and I think I've put some strain on his marriage now that he works from home, because that thing is gnarly.
Let's see. Let me see. Are there any keyboards that allow for micro SDs to be installed directly in it, such as having an entire OS on the keyboard?
Oh, that is a great question. I am not aware of any keyboards that you can plug in that type of external memory into in the custom space. I wouldn't be surprised if there's some like weird Razer keyboard that supports that. So the answer is I don't think so, but I'm going to take a look after this to see. And I recommend you take a look as well, because that's actually just taking a second. One of the things when I gave this talk at a local hacker group a couple weeks ago, One of the things that's a little bit limiting about using hit attacks, whether it's a USB rubber ducky or a keyboard, is that it's sort of like one-way communication. You can't really pull information from the machine to sort of act contextually. So that's why I like having a bunch of different payloads there. But that being said, like, I wouldn't be surprised if there's some mad scientist in a garage somewhere who managed to put in a micro SD card reader with the firmware on there for a keyboard. We just have to track it down. So that's a great question.
And let's see, how do you add non-English language codes on these keyboards?
There in QMK, there is a ton of different key maps, or excuse me, key codes that you can put in there. So there's a couple different ways you could do it. I will have to double check to see if QMK supports those non-English key codes. Actually, kind of a glaring oversight on my part. I apologize, I didn't check for that. But you could definitely have SendString macros that do the like Alt, 137 or whatever to get the, like A with the E jam next to it kind of thing. So I will double check on that, but check on qmk.fm because that should be documented on there. It's a great question. Wow.
Since a keyboard is a microcontroller, is it possible to get my keyboard ransomwared?
That's a good question. So the answer is probably not. And the reason for that is that when you are flashing the firmware onto your keyboard, you have to put it into like a special mode that allows you to send the firmware to it. So the QMK toolkit that you will probably use to flash your keyboard, I don't believe is able to send the actual reset code to the keyboard to be like to put it into that boot mode that you need to write the firmware for. Because most keyboards, like all mine, for instance, I hit lower and raise and then the Q button, and that will reset it and put it into that mode where you can flash the key. I want to say it's DFU mode, but I may be incorrect on that. To actually put the keyboard firmware on there. What would be more devastating is if I like put some ransomware on your machine and like attacked your QMK key maps that you wrote for yourself. Because if you didn't back those up, then they would be gone. But yeah, unfortunately, you're not going to have well, fortunately, you probably won't have to pay a Bitcoin to unlock your keyboard. Because Bitcoin is now a little bit more expensive than a mechanical keyboard. It wasn't when I first got started, but now it is. So.
And there was a follow-up question about mitigations, which kind of ties into a question that I was going to ask, which is, aside from taking over someone's machine and having their laptop yell at them on loop, maybe what are some simple steps that security personnel can take to secure devices against hit attacks?
Yeah, that's a fantastic question. So one of the things that I do is I have USB locks, where if I don't have something that's plugged into a USB port, I just put a lock in there. They're pretty cheap. So you can, sort of deny physical access, right? Everyone's heard the story about, I think it was the DoD epoxying all their USB short ports shut. Probably wouldn't do that. It's probably somewhat damaging to the system. Another thing you can do, and this is, you're able to defeat this, but you could, like when a keyboard enumerates via USB, it'll tell you the manufacturer, and you could have a whitelist, let's say, or excuse me, an allow list or a trust list of allowed keyboard manufacturers. If you're familiar with OUI in like MAC addresses, I recommend the same thing, right? If you have a network full of Lenovo's, why would you ever let a Apple machine on that network? If you have a network that's full of, Dell $5 keyboards, why would you ever let a, Razer, like Super Gamer XL 5000, whatever keyboard on your network? That can be spoofed. Like for instance, my keyboards enumerate is just Dell, like standard multimedia keyboards, but it is, like that's why we do defense in depth, right? Not every step's going to work 100% of the way. So that's certainly one thing that you can do. Yeah, I'm hesitant to say like don't let people bring in their own hardware, because if I go work at any of your companies, like I really want to bring my own keyboard, but yeah, actually another one that it's the simplest thing to do is lock your machine. This is not a DMA attack. I can't like get around authentication, but if your machine is locked, all I can do is maybe try to put in a password, but like that's not that effective. I cannot run commands if your machine is locked. So just lock your stuff, which I can't believe in 2021 we're still fighting that. And I think I haven't thought this before, but it's actually just sparking some neurons for me. I wonder if we're going to see a increase in unlocked machines as we start to go back to the office, because I don't lock my machine when I get up to go get lunch because I don't think my wonderful 4.5-year-old son is going to come steal all of our trade secrets. So yeah, I think we all as security professionals should be on our toes and educating people on the dangers of leaving their machines unlocked. At the company that I work for, that again, you may have used to pay your pals with, like I am constantly doing these demos to show people this is why you need to be locking your machine, because it takes 3 seconds for me to get access to a remote machine. Another thing you can do, sorry, is if you so you have like north-south network communication where, like, let's say you have a machine, you're communicating with a cloud service, that's pretty normal. But if you have one machine here and another machine here on a network, do they ever really talk to each other? Because the answer is probably not. If you're going to email, person A is going to email person B, they're going to send an email up to an email server, and that person B is going to retrieve that from the email server. If you're going to share a file, you're probably going to use OneDrive, right? And they're going to go up to OneDrive. Why then will I ever talk between A and B? And I'm seeing a lot of success for companies shutting that type of east-west or horizontal communication down. And the only reason that my attack worked before is since I was on the same LAN, we didn't at that time have east-west lockdown. So I was able to connect directly. So good network segmentation, lock your machine, potentially using like physical hardware to block access to USB ports, and potentially filtering out different types of USB like device manufacturers around keyboards or mice. Because remember, a mice also has a microcontroller in it. You can plug it in and probably still send commands. So you got to be real careful about what you allow people to plug in. Those are some of the many ways I'm sure that you could do some defense around this that's not too invasive to your actual operating system, like running a keylogger.
All right. Well, that was awesome. Thank you very much for your time and for this presentation, Kevin, and bringing this information to the community, especially getting people excited about mechanical keyboards. Hopefully we'll get more clickety-clackety people out there. That would be pretty cool. To our audience, we greatly appreciate you listening in. We appreciate your time as well. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. That's a / of course. Until next time, take care, and we hope to have you back again for another SANS webcast. Bye-bye now.